This is a video lesson on the optimizing rule, which is also called the objective rule. And this comes from the idea that typically the purpose of a system of inequalities is to find the optimal point or the optimal solution. Optimal means best. Specifically, that means looking for the maximum or the minimum of some value. And we'll talk about what that value is in just a minute. And one thing that's really important, there's a theorem in math about it, but you just have to know that the max or the minimum value will always occur on the border of the polygon of constraints if the lines are included. And what that means is that this topic is very closely related to the math that we had already done, where we had to graph inequalities and solve for their points of intersection. So I'm going to review that quickly here as well. And finally, optimization only really makes sense in a word problem. And that's why we hadn't discussed this idea up to this point. So here's an example. It says a coffee shop sells regular coffees and iced coffees. They sell each regular coffee for $2.50 and each iced for $3. They make at least 30 total drinks. They can't sell more than 90 total drinks. They sell at least twice as many regular coffees as iced coffees. What is the maximum revenue they can make? This is the part that's new. This is the part that's called the objective or the optimizing rule. So not only do we have inequalities, not only do we have variables, but now we're looking for the maximum possible revenue. And that's related to this part here, this 250 and 3. So the first thing you will always have to do in a word problem is to define the variables. Here I will define them for you. X will be the number of regular coffees and Y will be the number of iced coffees. And the second thing will be to write out the inequalities. If you want to pause and try that for a minute, I encourage you to do that. I'm going to go ahead and show them now. There's one. That's X plus Y is greater than or equal to 30, at least 30 total drinks. That's the sum. They can't sell more than 90. Again, if you hadn't paused before, you can pause now and try the last two. That's X plus Y is less than or equal to 90. And they sell at least twice as many regular as ice. That works out to be this one here. At least twice as many regular means we have to multiply the iced by 2. It's the smaller amount. There are two additional inequalities, and I'll show you those in just a second. There's 1, 2, and 3. The last two are that X and Y both have to be greater than or equal to 0. In just about every word problem we'll do, you can't have a negative number of items. You can't have a negative number of regular coffees or a negative number of iced coffees. So we add in that X and Y both have to be greater than or equal to 0. That will come into play in many examples. And before you do anything else, you should look for the objective rule. And the objective rule has to do with what it is that we're trying to optimize. The question asked, what is the maximum possible revenue? It means we're trying to optimize our revenue. And the rule is a mathematical word for an equation. And the equation for revenue is that R is equal to 2.5x plus 3y. It's $2.50 times each regular coffee plus $3 times each iced coffee. Now that I've got all that, I have to graph each inequality. If you would like to pause and try to graph this one, I encourage you to do that. I'm just going to show you what it is. If you isolate the y, you get y is greater than or equal to negative x plus 30. That means an initial value of 30 and a rise over run of negative 1 over 1. Or if you found another point, I found another one at 30, 0. So that's my line. Y is greater than when it's isolated. That means shaded above. If you want to pause and try the second one, again, I encourage you to do that, but I'll just show you the answer. Initial value of 90, again, a slope of negative 1 over 1. So my next point is going to be there. Or if you found another point, I found 90, 0. That's my line. The y ends up being on the less than side when it's isolated. That means shading below. And the third, if you want to pause and try it, go for it. Once you isolate the y here, you get x over 2 plus 0. That means that there's an initial value of 0. And it means a rise over run of rise 1 and run 2. Or if I found another point, I found one here, but that follows the same line. And the y is less than, that means that it is shaded below. Now, normally this would be this entire region in here that gets shaded, but because we have these other two inequalities, x is greater than 0 means everything to the right of this line, and y greater than 0 means everything above this line. And that means that we're only in the first quadrant. That's this corner here. So it means that we're only to the right of this axis and above this one, or including. And that means that the polygon of constraints is here. It is completely closed in because it can't go below this axis. Next, I will have to find the coordinates of the vertices, the corner points of that polygon. So if you want to pause and try that, go for it. If you already know how to do that, that's fine. I'll just quickly remind you that what I've labeled here as point A is on the blue and the orange lines. The blue equation was x plus y equals 30. The orange was x equals 2y. And I would solve that either by substitution or elimination. I did substitution here. So you can go through those steps if you need to. And this works out to be the point 20, 10. Those are the coordinates. Point B is on the red and the orange. My red equation is x plus y equals 90. That's my orange. I solved by substitution again, and I got the coordinates 60 and 30. Feel free to pause at any point if you want to write stuff down and I'm moving too fast. Point C is on these two lines because the other one is this axis where y is 0. And when I substitute, I would get this, although you could theoretically read that one off the graph. It's a good idea to get into the habit of doing it algebraically because you will be required to do that on tests. And point D is on this line and also the line y equals 0. And when I plug that in, I end up finding that x is 30 and that y is 0. That's my point D. So finally, how does this come into play with that optimizing rule? Well, the revenue in this problem we knew was equal to 2.5 times x plus 3 times y. 2.5 times the number of regular coffees plus $3 times each iced coffee. And what I would do is for each one of these points, I would plug in this x and this y. So here I'll do 2.5 times 20 plus 3 times 10. And when I plug that in, I find the revenue at point A. I don't really have to write this part. But point A generates a revenue of $80. Point B, point C, and point D generate these revenues. And what I'm looking for is the single point that has the greatest revenue, the single point that has the highest revenue. And that is that highest revenue. A question might ask, what's the maximum possible revenue given these constraints or inequalities? And that answer would be $240. A question could also ask, how many of each type of coffee do you need to sell to obtain the maximum? And then your answer would be 60 regular and 30 iced. So it depends on how the question is being asked, but that's how to go about it. And quickly, I'll show you one final example where I've already graphed the polygon of constraints. I've already found the coordinates. I just want to show you again how I would, let's say, solve for the max or min of something. So here I've made up a context that x is the number of calculators sold and y is the number of pencils, and I will have made up an amount of profit, not revenue. Sometimes you'll have to calculate profit, knowing how much you sell something for and also how much it costs. But here, if I've told you that each calculator makes a profit of 2 and each pencil makes a profit of 15 cents, then what you would do is set up in your table an extra column that has profit in it. We know that the profit rule is 2 times x plus 0.15 times y, and I would plug in each point to figure out which one generates the maximum. So again, just as a reminder, even though the shaded region shows all the possible number of pencils and calculators you can have, the max profit can only occur at one of the vertices. And when I find those values, it turns out that this is the maximum value here, and that's the maximum possible profit in this context.